Wow, so last talk of the conference. So yeah, we've both been working at some new secret products that we can't talk about, but the important part is they do use JUCE, and we've been discovering how we can use JUCE into this product to build UIs that feel fluid, that feel like they're part of the product and not just slapped on. Like, there's two parts of this. There's the design aspect, which is what Amos is going to talk about more mainly, is how do you approach this from both this, a visual interaction, hardware design, and then I'm going to talk more about like the implementation discoveries or best practices or cool tricks. Anyway, I thought it was cool. So maybe you will learn something from this. It's really very targeted towards what we're doing. But it might be inspiring for some of your products. So very quickly, we can't tell you about this product. So it's got a central LCD. It's got a front panel that has hardware controls. It runs Linux at its core, on which JUCE is being run to actually display an interface on the LCD. And the advantage of JUCE is that we can develop very easily on the platforms that developers use, mainly macOS. And then run it on Linux very easily. And so these are the things that we want to share. There are 6 main topics. It might be a little bit fast-paced. We're trying to get this done in time. So with that, I hand it over to Amos to talk about first design aspect.
Thank you. Yeah, so my role is essentially the hardware and UI design and specifying the product as the user interacts with it. And so specifically what I design is musical instruments, but a lot of the considerations are the same as any sort of music software because it's still a creative tool. So what I've learned designing creative tools I hope will be helpful directly or indirectly to other sorts of designers of creative tools. And so in any case with a creative tool, everything that you do, all of your design, that's really amazing. I won't stand there. Okay, that was you? Wow, okay. All right. Yeah, so you want to design create a state of flow exactly unlike what just happened, which was, entirely shaking me out of a state of flow. Essentially, you want your UI to support the user's interactions. You want to create positive confirmation and support the user's creative process. If they have to stop and figure something out, then you've shaken them out of that state of flow. So you want immediacy and immersion, and you want to support the user's intuition. And so you're creating like a playful space for the user to work. And so some of the things that are specific to working with a physical piece of hardware as opposed to software, you have an actual physical display that's different than your laptop display or a desktop display. So some of the things that you need to think about when you're working on that is it may render colors differently. If you're working in the producer and you have a designer that said, here's your color palette, you want to be able to iterate that on the hardware itself because the color rendering may be different, the gamma values may be different, and the contrast and how legible it is from a distance may be different. So you want to test your color scheme on the real hardware, and you also want to make sure to check it under a variety of lighting conditions. A lot of users, they're going to be in a very dark room with like no ambient light, and you want to see how it looks there. You want to look at it under direct natural light. People may be using this thing outdoors. Your office space is probably going to be something like for overhead fluorescence. And all of these things, you'll have different contrast, and you need to make sure that your UI scheme that you've designed is legible, is visible under all these conditions. And another thing about a physical LCD is you have angle, and contrast can actually change with viewing angle. And so, if you're a software developer, you may not have any control over that. That may be a hardware development thing. But if you're picking a palette, you can pick a palette that doesn't become too low contrast at an extreme viewing angle. And so these are the things that you need to look at. And with font rendering, something that we discovered as we developed is the same font. You know, you've got a font that you've packaged into your project in JUCE. That's great. You call the same binary resource in Mac OS and in Linux, but the actual rendering of that font on the screen is going to look a little bit different. We found that in Mac OS, the fonts actually render a little heavier than they render. I see some of you nodding your heads. So it's not going to be pixel perfect. So if your target is a different OS than you're developing on, you absolutely need to iterate. You need to go back and forth and make sure that everything lines up where you think it's going to, or that you compensate accordingly. And when you're working with refresh rate on an embedded system, you've got one CPU and you've got your various threads, and some of them are rendering audio and some of them are rendering your GUI. And you might want this like super fast, 60 frames per second, like really nice responsive UI, but that's taking cycles that you may need for your audio processes, or that you may need for scanning your controls, or everything else that you have to do. So one of the considerations when you're designing for this kind of environment is dialing in a refresh rate and optimizing your repainting code so that you're not doing more work than necessary. So think about whether you need animation, think about how crisply you need to be able to update, and then balance that. So write intelligently so that you're not doing more graphics update work than you need to, because you're sharing those resources from a limited pool of cycles on your embedded hardware. And the last note I had here was about glare. This is something that, again, is you might not need to worry about in if you're developing a piece of software, but if you have a piece of hardware, again, this is more of a hardware consideration, but like the bezel that you use over your LCD, the geometry of the lens, the coating, all affect how visible your graphics are going to be. And so these are things that you need to get them as right as you can, and then design your graphics accordingly to work within those physical limitations. And getting back into making an integrated instrument, at Moog we call them hard versus soft controls. And hardware controls are your fixed purpose controls. If you're making a musical instrument, you may have keys, you may have dedicated buttons that only have one function. And when you're designing a system, you want to try to offload those things that are the highest frequency, the things that you need to use the most often, the most repeatedly, the quickest response time. Ideally, you don't want to put those in your GUI, because you want to be able to get to them more quickly than that, and you want the fluidity of the use of this thing to support that. So things that you need immediate access to, things that you need to use very often, functions that you need to perform very often on the instrument, you want to try to take those out of your LCD GUI and give them physical controls if you have the budget to do that, if it makes sense to do that. That's sort of the organizing principle that you want to use when you're determining what's going to go on the LCD versus what you're going to support with a physical control. And then the soft controls are those ones that are intimately related to the GUI. They're defined by the software, and most of what your GUI is doing is showing you what those controls are doing, showing you the response to those controls, and giving you feedback on where you are within the system and what's happening when you're turning a soft knob or pressing a button that's associated with one of those controls. And so this is a common language that's used. This is a Machina Studio and a push-to controller, and in both cases you've got your rich immersive GUI with some buttons that might have some multicolored, ideally they're multicolored LEDs, and then you've got some encoders that probably, if you push them, there's probably a switch there also. And all of these, this is sort of the common design language of what are the generic controls that work best next to an LCD. And as you see on the LCD, your visual elements, they're lined up sort of on a grid with the physical controls, so aha, the data that is showing above this knob is what's going to change when I turn the knob, or the label that's next to this button is what's going to happen when I press that button. And additionally, you can use color in the LCD, and you can match the color. If you've got RGB LEDs under your buttons, you can coordinate the LCD colors with the button colors to cue the user to exactly what's happening, and you're bringing the design language of the GUI, you're extending that out to the physical controls that are the nearest to it. And you know, with space and with color, you coordinate these things so that they create a cohesive UI that the user doesn't think, oh, now I'm working on a little screen. It just feels like it's a part of the instrument as a whole. It sort of extends the user experience outside the LCD and into the surrounding controls and makes it feel like one thing. And here to talk about how to do that on a technical level is my esteemed colleague, Geert Bevin.
Let's try to turn this on again.
Careful.
Oh, yeah, it's working. So the first thing that we sort of noticed and actually completely embraced is the producer. It is one of my favorite features of JUCE, even though I know that Jules doesn't like the graphical editor. But having used many of them in the past, I think that the producer and notably the graphical editor actually strikes an amazingly good balance. But the first thing that is interesting about the producer is that you can have this centralized project management of all your files, and you don't have to worry about the target platforms. It means that one person makes a change. When it's running on Mac, it has generated those project files, but it automatically, so it's created those Xcode files, it will automatically also create, for instance, the make file. So you're always up to date. You always know that whatever changes you've made to your project, whatever files you have added, will always have updated the make file that will be run, for example, in continuous integration when the builds are being done for, for the next revision, when testers are testing it. You're pretty certain that that is kept in sync. So the next part of the producer is the WYSIWYG editing, which is pretty handy. We work a lot like this in that Amos designs graphics and layouts pretty easily by using graphic primitives. So you get all these controls. You can create a new text button, create buttons. You can line them up any which way you want. So in this case, creating a panel that has like a little oscillator graph on it. And one of the things you'll notice, this is just an example. I've got two main elements here, which is the surrounding frame, which is, let's say that this particular wide border would always be used on all the screens with this particular title. It is present on this particular oscillator panel, and it also has an oscillator graph. One of the advantages of the producer is that you can actually structure those as individual components. So instead of having to create each panel with all the controls individually, you can focus on the reusable parts, not only in the implementation, but also in your visual language, in your visual vocabulary. You create these components that you design in a way that is adaptable, so they might resize based on the surrounding frame, or they might have a fixed size. They can also be configurable. Let's see if I think I've got an example here. No. But in this case, so the example is that it can take a constructor argument that will set the actual title of that panel. So when it is used inside the surrounding panel that imports that particular component, it will set through the constructor argument the actual text that is being used, and you can use it for a whole lot of other customizations. The nice thing is that if you consistently apply this, you will inherently build out a visual vocabulary that is the identity of your product. And as you move through it, just like when you design your classes in a code level, you will design your visual components in a similar way that is super reusable. So this is another example where it actually, you can draw this graph. There are two facets. I guess I'm repeating things a lot of people know, but I like to highlight that you can also create regular graphics in the producer. It's not just for widgets. And we found a nice sort of technique to still rely on the graphical drawing routines of the producer and then customize them later on. So that's the next aspect of the producer. If you've never really embraced it fully, this might be interesting to look at. So when you see the code that is generated from the producer, you see like a whole bunch of comments there. And these are insertion points. These are points where you are safe to make changes in between those comments. So it usually is in the beginning of the method, at the end of the method, and every time something meaningful is being instantiated or configured. In this case, it is in the constructor, I can set, for instance, local member variables to particular default values. You also have in a header file corresponding comment sections that allow you to add those member variables and make those classes much more functional than the basic graphical aspects that you're drawing. So this is another example. For instance, for this graph, this oscillator graph that you just saw, what we're doing here is in the paint routine, it will actually use a path that has been created and paint that whenever it's needed. But the path is only created when the widget is resized. So what you can do is, everything that is like dim is what the producer has generated. What you can do is basically just clear that path and then start customizing it. So in this case, we've created an additional method that inspires itself by the examples that you've graphically created, so you don't have to figure out all the dots and what the dimensions are of your drawing calls. You can still visually see in the visual editor when you compose out of these components all your graphical elements what it will look like, but it can also completely replace the graph with procedurally generated graphics that might be real time or that might be tweakable due to some front panel controls. So it sort of mixes all the different concerns when you're creating a UI. There are some people that will be focused on the more visual layout aspect of it. Some people will be composing other panels out of reusable components, and some people are really focused on getting those real-time routines dialed in. And it allows you to really focus on all those individual aspects. So the final point to make about the producer is that you can very easily embed external resources, for instance here fonts. What is the advantage of that, and create like a dedicated look and feel for it? What the advantage of that is, if you embed your external resources, everything that you need, you end up with a single executable that will run everywhere. So you can run it very easily in any CI environment. If someone makes a build that is quickly out of the entire flow of the build system, they can just hand on one file to another person. And everything will always be up to date. You don't have to worry about all the fonts being installed, about any kind of other external resources not being available. So handing it back over to Amos.
Okay. Thank you. Yeah, so again, talking about the design aspect of it, one of the things that we focus on is having a consistent grammar of how the user interacts with, with these sort of generic control elements, so that it supports, and again, it supports their intuition. You want to apply similar user interaction metaphors across different contexts, so that if a user learns how a set of controls is going to affect the environment, then you give them a new screen. They don't have to relearn what's going on. They don't have to worry that they're, is this the right move or not? The idea is, the similar moves should have similar effects in every context. It allows the user to anticipate what the right action will be in a new context. Again, with predictability, it supports their muscle memory and they get fluid navigation. For example, we created a move for reordering items within a list that, you've got a rotary encoder, you've got a shift button, you're turning the rotary encoder and it scrolls through the list. You hold shift and turn the rotary encoder. Shift is grabbing the item on the list and reordering it up and down. And it turns out that that was a sensible thing to do, say, on a list of presets. It was a sensible thing to do within like a sequencer environment where you have some data. It was a sensible thing to do in another matrix environment where you were dealing with rows and columns. And certainly we could have said, oh, this is the matrix. In the matrix, you've got some other move that you use for moving things around. But if you zoom out and try to conceptually generalize, the more that you're able to do that consistently and apply the same moves in conceptually similar situations, the better it's going to be for the user. And so when you're designing these sort of navigational widgets, there are some sort of overall lessons that we've learned to help support the user experience again. And you really do want to try to focus and focus the environment and limit what users are asked to do to a small enough set that they don't have to carry around a big instruction manual in their head. Ideally, you want the UI to suggest or show to the user how it should be used. And you know, the most that it could be self-explanatory, you know, the more that it can be self-explanatory, the better. And because this is sort of a difference between working with a general purpose environment or a computer where you've got a mouse and a keyboard or text shortcuts, things like that. Typically, you're creating an environment where you have a very small number of controls that can do things like increment and decrement, or you know, you've got push buttons. And you know, whoever is in charge of the cost of hardware will say, we want as few of those as possible. So there's definitely a balance between, you know, how many points of user interaction you have, how many things you want to do on the screen. And again, so what we've learned is that you want to keep that as shallow as possible. And you know, shallowness, that's referring to, I have a menu of options and I can click into that and that takes me to another menu of options. You kind of want to stop there. You don't want to click through to a third or a fourth layer of depth because it becomes a disorientating and unpleasant experience typically for the user. And so again, this is getting back to what I was saying earlier about understanding what are the most frequently done things or the things that need to be done the most quickly. If it's possible to create dedicated functional buttons for those things rather than choosing from a list of options, that's going to be quicker for the user. If you've got, like, say, 4 main UI pages or contexts, you know, one's for performance, one's for setup, one's for configuring global settings that you're maybe going to need to do once for a session. You know, it's wonderful if you have the space in your UI to make, you know, the performance mode is a button, or, you know, the global settings is a button. If you have to put that within your GUI, that's okay, as long as you don't have to navigate too many layers or shift too many dimensions in order to do that. And if you do have to have lists, it's good that they not be too terribly long. That's one of the things that we learned. I might use as an example modulations. You know, if you've got a matrix of modulations and you know, in a perfect world, someone says, hey, I want to be able to modulate every possible thing. That is a noble ambition, and it's great to want to be able to modulate every possible thing, especially if you have an amazing sound engine that has a ton of parameters. That sounds great on paper, and it's also really good in a nice general purpose like plugin environment. You know, you've got Massive or something, you've got drop-down menus, you've got pages where you can, you know, you've got keyboard shortcuts. That's great. If you're dealing with like a 3-inch by 2-inch LCD and you've got like a little thing to scroll with, you really don't want a list with 100 things on it. But it's fairly easy typically. This is not an example of our awesome in-house UI design. This is was done here in mere seconds. But basically, if you've got 99 things on a list, can you turn that into 10 categories with 10 things? And then you've got, you know, cursor up, cursor down, and then you're only scrolling through 10 things in your other dimension. That's immediately a much friendlier user experience. You're not going to get lost. And as long as you can chunk these things sensibly and categorize them well, then, you know, you've created a much friendlier user experience within this small environment. One of the metaphors I use sometimes, you know, this is sort of an example, a way you would describe a bad one of these embedded UIs is it's like building a ship in a bottle. You never want to make your user feel like they're building a ship in a bottle or trying to do too many things through too small of an aperture. So, you know, clarify, simplify, chunk, and organize these things, and you'll create a better user experience. And so I think I started to talk about these things earlier. These are just, you know, simple moves that you can do if you have just a rotary encoder and a push button. You know, you can use those contextually in really sensible ways. Rotating an encoder always feels like it's kind of incrementing or decrementing something. You could be incrementing or decrementing a value if you have a value selected, or you could be incrementing or decrementing a list position if you have a list selected. These are both really intuitive feeling things. And then if you add a modifier to that motion, then, you know, what's the sensible thing to do with a modified increment? Like, okay, as I said earlier, grab something and move it. Pushing a push button kind of feels like grabbing a thing. You push, you know, you've selected and then you move. That works really well. Just pushing the encoder, that's you know, that's a good way to do a cursor. If you have an extra button, so a couple of these like press and shift press, these are examples where, depending on your UI, if you're limited to only one push button and an encoder, great, you combine the two. Otherwise, maybe your product designer says, you know what, you can have a cursor button. Great, that unburdens the encoder from that role. So you've got a separate button for cursoring around, and then you can just do the encoder. That's a little bit easier. For shift press to confirm an action, great if you don't have an enter button. But maybe you think about the product and you've got the budget for and the room for an enter button, and again, you've unburdened another control. One thing that's, there's sort of a tension between meta functions, like shifted functions. Those can be really good if you have a very small UI and you have to maximize what you can do with a minimum number of physical controls, but it's always worth thinking about, is that, am I making something modal that it would be much easier for the user if it wasn't modal? Can I add one more control to remove a shifted function or remove a modality? And you know, in some places it's very natural and sensible to have modal controls. In other places it's, you know, you have to think about it, and ideally you prototype it, or you know, you can mock it up virtually and get a user to try it, figure out where it makes sense and where it doesn't make sense, because it can, you know, again, in some places it feels natural. That's where you want user feedback. Does this feel natural or does it feel awkward? And you know, ideally you want to run through these things in a mock-up form before you've decided on your final hardware, if you can. If you don't get that choice, which often as a programmer you don't get that choice, you're given something, you just have to work with it. That's where you just sort of, you know, make the smartest UI decisions with a fixed control set that you can make. And you know, experience helps with that, and user testing helps with that. And back to Geert.
I think we're gonna make it in time.
Amazing.
Yeah. So another approach, and this is really dependent on, you know, the resources you have in your system. So we found that within the constraints of what we had to work with, what we had the most available was memory. So that's something to use and to leverage. One of the biggest advantages you can do with memory is to do as much work up front, so that when the user wants to do an action, that everything is just snappy and immediately there. You don't have to instantiate things. You don't have to do lookups whenever you display hidden elements. So for instance, you know, when we create the main components of the JUCE application, this is just a small excerpt. You know, create all the panels necessary. So we're in reality, we're talking about dozens and dozens of panels. These are just 4 of them. And what we do is we create all the panels, we add them, and then we hide them. But they're there. They're already laid out. They're ready to start working. And whenever we need one, then we can say, hey, show a panel, and it will hide all the other panels and just show that one panel that has to become available. And the action is completely immediate. Everything that has to be up to date in order to inform the user is already up to date, because the panel, it was alive to receive all the updates to the widgets. It probably will not have done the render calls or the layout routines to actually get the pixels figured out, but all the data is there. So in terms of your task as a developer, you basically don't have to do anything anymore. This is all leveraged, you know, done by JUCE, because JUCE knows what to do whenever something has to be displayed and be kept up to date. So I'm just walking you through here this particular mechanism. So we create this panel, create a whole bunch of panels, hide them. One will be shown, and then in each panel we've got a system basically that has a unique identifier for each parameter in the system. It's just an enum. In this case, it is the rate of an LFO. And I'm registering an instance of a class that we call the component updater that is basically able to update that particular control that corresponds to the label of that LFO. When this panel is instantiated, it also instantiates that updater class. It hooks them up, puts them inside a global hash map, and all this happens at boot time, basically. It's quite fast, because at that time, at boot time, there is not much competition for the CPU. There is no real audio that it has to be processed. It's just booting up, and we don't really feel it. The advantage is that afterwards, since everything is just set into a map, it's got unique indices, whenever a component needs to be updated, we just have this one call, update component, and it will immediately find the index of that enum in the hash map that contains all the component updaters. It will call straight into the widget that is possibly inside a hidden panel. And inside that hidden panel is going to update it, and it's going to be ready to be displayed if the user switches to it, if the user wants to see what is going on. One thing to be aware of, though, is there are some routines inside JUCE, like for example text rendering, that will, even though the paint method will not be called to display it, it will still do some metrics on the text. So how do I have to lay it out when the text is updated? So what we did find was that we had to manually set the visibility of all the child components inside such a panel and keep them in sync, just to prevent, let's say that someone is very rapidly turning a knob on the hardware panel that is sending that message which is linked to that unique index that controls the rate of that particular LFO. It can be a whole bunch of messages that come in, and if for each value update it will start re-rendering the text even if it's not visible, and this happens for all the panels that are hidden, you will see the CPU spike immediately. But just simply hiding all the child controls in this manner will actually alleviate that concern. So that was a little bit quick about this particular topic, but we'll hand it back over to Amos.
Oh,
design.
already? Okay,
Yeah.
sure. Yeah, so the last thing that I wanted to mention, this was like a huge help for us in the development process, and might be a good takeaway for people here, is the use of a virtual panel. This is the idea is we have one team of people that are designing the GUI in JUCE, as we've been talking about. And then we have, of course, this is embedded in a hardware product. That means there's a hardware development team. They're working on the actual system that this front panel is embedded in. That's going to be something that is scanning all of your front panel knobs and switches and all the other inputs that are being processed by the system and that are ultimately responsible for the things that Geert was saying, like, okay, we're changing an LFO rate with a dedicated knob, and that's going to flow into our GUI, and if you happen to be looking at the LFO, it's going to be drawing a picture and updating a text value and so on and so forth. But none of that stuff in reality is going to happen in your GUI system that you're developing until or unless you have hardware. And the hardware development process and the time for getting hardware and having a prototype on your desk, like, you don't want your whole team sitting around waiting for the hardware guys to get their act together. So what you can do is you can create a simulated hardware UI on your development system. You know, it's got a picture, basically it's like a plug-in GUI essentially of what your hardware front panel will be. And it can send the exact same messages to your GUI application that the hardware will send when it's ready. And so this is something that we developed for our product. We created a graphical front panel that was, you could control it with the mouse, you could control it with keyboard shortcuts, and it would generate the exact same messages that, that our API was set up to receive. So turning your virtual front panel knobs would communicate. We were using OSC messages. You can use whatever protocol you want. Basically, you just send data from your virtual front panel that you design to simulate your hardware front panel, and that way, whoever's doing the GUI, they've got everything they need in order to get a jump start while they're waiting for the hardware to get debugged or to come out of production or to get first articles together. You don't have to wait for any of that because you've got a simulated system that gives you the exact same messages. And we found that, and another really good thing about that is if you're collaborating with people over a distance, we have a distributed team, so the people that are working on the hardware are on one continent, and Geert is working on the front end on another continent, and was able to, this is another nice thing, if you have to iterate your hardware, it turns out we're not gonna have that knob, we're not gonna have that button, we're adding a button. To change that in hardware, it's a huge issue. To send that hardware to your remote developer, it's a huge issue. To update a virtual front panel, add a knob, remove a button is trivial and easy. And once again, the GUI developer is able to stay in sync with what the hardware is going to be faster than you can actually iterate the hardware. So this technique has been hugely useful for us as we're going through various hardware prototypes. It cuts down on the waiting time, and it means that your GUI development can be super reactive and responsive faster than you're able to get the hardware. And then when you do get the hardware, it matches your expectations, all the signals are correct, all the visuals are correct, you know how everything is going to interact with everything else. And so that's a very powerful and useful technique that we found that, that we wanted to share. And back over to Geert.
Yeah, another, maybe tiny little note about the virtual panel. One thing you can also do, which we did, was to actually hook them up to touchscreens. So if you've got sufficiently large touchscreens, you can actually interact with it and get already a feel of what the product will look like and feel like. And if the motions that you're imagining in your head, like all those UI controls, if they physically feel like something that does feel natural before actually building the things for real.
Right. Goes back to my point about if you have a shift and a shifted function on a knob, does that feel right? You can actually you can prototype it on your virtual panel and test if that's a workable motion or if you need to rethink it before investing in the hardware to do the same thing.
Yeah. So final point about automated tests. So there are various different types of tests that you can do. I want to test way more than I'm able to because you're always hitting against time constraints. But one of the things that I like about JUCE is that it's actually quite easy and straightforward to write UI tests that are semantic in nature. And what do I mean with that? Instead of, for instance, writing a robot that will click around and move a mouse or turn a control, you can use JUCE's component system with the component identifiers to give semantic meaning to individual parts of your UI and query their values when your tests are running. So for instance, again, about the LFO, imagine you've got this LFO panel, it's got that rate label that has been updated. What you can do is, I don't know if you remember, probably you don't, but when I instantiated that LFO panel and had that label on the LFO panel, it actually assigned it a particular identifier, a string identifier, that is very easy to look up later on. And so we extended JUCE's unit testing system to be able to write GUI tests quite conveniently. This is really shortened, but so the flow is, as Amos says, we decided to use OSC as a protocol to communicate with the hardware and the actual UI. So generate those OSC messages so that your UI gets into a state that is predictable, which might be get to the launch screen or whatever, then generate those messages that would make a particular update to the UI. And if you've assigned those unique identifiers to the components in the UI, you can use, for instance, in this case, a method that is quite easy, find component. It will take an array of strings which are being treated as a hierarchical series of identifiers. So it will look at a particular top-level component and then traverse down to find a widget that is lower level, in this case, the rate of the LFO. It will find that, and for instance, in this case, it's actually not, it's the first test. It's checking if you press a particular control on the front panel, are the users going to see that panel? So it's checking the visibility of that particular UI panel, and the only thing I have to do is, okay, if these button presses happen on the front panel, if these messages are generated, will I then see the expected result, which means, for instance, all the other LFOs are hidden and only one is visible, which is the case here. The advantage of this is, compared to other UI testing techniques where you would, for example, detect the presence of something visually or the location, if you design your GUI tests like that, it's extremely brittle. If someone comes along and says, hey, I actually want a completely different design, this control has to be left instead of right, it means you have to rewrite all your UI tests. But if you structure them in this way, you actually are testing the exact concerns that matter for this particular functionality and not the output, the visual output of the graphics rendering. And so this was the other example I was talking about, evaluating if a particular label for the LFO has been updated when front panel controls change. again, you create assertions, you make sure that you start from a clean slate, make sure that those labels are in a state that you know is predictable. In this case, I will just clear the labels. Then simulate all those front panel controls and use the same system, this series of identifiers that allow me to traverse the components to get at that label and evaluate, does it actually display what I expect if I've turned that knob on the real hardware panel? And afterwards, I can change layout around as much as I want. It will not have any impact on my GUI tests. One small side note, I don't know if you noticed this, you can also very easily write a routine in JUCE to capture the content of your actual panel that you're displaying. So creating a screenshot and write it as a PNG. So we do that for all the GUI tests. It's not something that we use to test, but it's something that we use to evaluate after the fact. If a GUI test fails, we can always visually go back and look at what happened in CI and see, hey, what does the screenshot actually look like? It is a very easy way to quickly identify as a human what might have gone wrong instead of going through log files. Another nice benefit of that is that you've got a very convenient way of generating screenshots of your UI. So if you have to write a manual, you actually have everything there and you've got the infrastructure to generate all the images for your manual because you can just write the tests that would switch through those panels. So next, and that is, you can use JUCE for running unit tests. I just wanted to mention it. It is quite powerful to be diligent about unit testing all the fundamental pieces of your application. If you've got particular routines that are critical to the functionality of your app or front end, don't forget to write the unit tests. It's such an amazing feeling. I had forgotten that because in my previous job I wasn't doing that much testing, and now I was able to get that back introduced, and it's always such an amazing feeling when you've got like 20,000 tests running and you know exactly what is working, and you can very bravely make changes without being afraid of ruining low-level functionality. So here are a couple of tricks that we're using in the way that we run tests. So similarly as packaging the resources as binary data inside the application, we actually ship with all the tests. So the application tries to start the tests when it starts up. And it does that based on a number of heuristics. So first of all, if it's running as a release version of the application, it will by default obviously not run the tests. But if it's running in a debug version, it will by default run the tests, which means that every developer that is running it will have to make a conscious choice to turn off tests, which, it is like a little bit of a barrier to run, to not disable tests. And then if there's a parameter in the release version that explicitly enables tests, it allows you to very easily, again, have this one executable that you can put on CI, and it's just one command flag that allows you to run the tests. Next thing we did was to run the tests completely asynchronously. So whenever the tests are being launched, there is a callback that is being put on the main callback thread so that at the start of your application, it will be sort of last in line, so that every initialization is done. Then it will kick off this thread that goes over whatever tests that you think are necessary to run. It might not be all the tests, and this is quite a nice little trick, I think, that we came up with. So as you develop your application, you will end up, obviously, with tests that can take half an hour to an hour to run if they're quite exhaustive, certainly when they're GUI tests, because they take time to traverse. So you can use it, the JUCE's test runner to, you have to explicitly add the tests that you want to run. So one thing we're doing, and it's a little stupid trick, but if you create your tests, let's go back to an example here. So you can see that the unit test has a name which is called bit-packed tests. And so what we did is, if you give it an empty name, the logic that runs the test runner actually will first look for all the tests that have an empty name and only focus on those. So when you're working on a particular class or a particular functionality, it's very convenient to just clear that name of that test suite, and all the rest will not be run. And when you're ready with that part of the code, you put the name back in, and all the tests will be run again, which allows you to very easily focus without having to recompile everything or without messing around with macros or defines or whatever. It's just, you're just focusing your attention on that particular piece of code. So that's that little trick. And I already touched on this. It makes it very easy, this particular approach, to use, for example, we use GitLab as a continuous integration system, but also for version control. Makes it very easy to integrate your application in the CI tests. And so it will generate the log files. It will also generate those PNG images I was talking about for the screenshots. And these are then all being captured by the CI tests assets collection mechanism and ready for use. Another nice side effect of having everything generated through CI, and it's just stating the obvious, but it is quite nice to have it, is that you always have an executable that can run anywhere. You can just take it from the artifacts that are being generated, and since all the resources are packaged inside the executable as binary assets, it's just one file that someone has to download and see, okay, why did something stop working? Let's quickly check with the executable from 2 days ago, check it with the executable from today, and it allows you to very quickly A, B, and see where something might have broken. So that's it. Quick shout out, we are looking for an iOS developer. So if anyone is interested, contact us. If you've got any questions,
that applies to you out there on the internet as well.
Yeah.
We see you. Thank you. All right. Thanks, guys.
Do we have time for a couple of quick questions?
Yeah, we have just a minute or two for questions.
Sure.
Go ahead.
Yeah. Is there a mic or? No.
I'll repeat your question.
All right. Yeah. Cool. I can speak up. You mentioned. No, sorry. You mentioned. One of you two mentioned the kind of mocking whatever GUI you're going to have, and that might change. But yeah. So, any chance you brought any pictures of that, or can you show anything?
So the question is, can we show pictures of what we're working on? No. Nope.
Unfortunately not. That's pre-release, so we can
Yeah.
only talk about our work. We can't actually show it.
Yeah.
Yes?
I just had a question about, so you're talking about making your virtual hardware interface communicate with OSC. So is that a separate application? Did you use JUCE to build that?
So the question is, what did we use to build the virtual panel that communicates over OSC?
That's right. It could easily have been JUCE. And in hindsight, perhaps it would have been cleaner to build it in JUCE. It happens for an assortment of reasons. We actually built that specific example in Super Collider, which also works.
Yes, sir?
You talked about developing a design language. Is that something that you can use across products? So do you think you could use that design language in your next product, or is that specific to the piece of hardware that you're working on at that time, and then it has to be thrown away for the next one?
So the question is the design language that we're developing for this particular product reusable across other products or specific to that particular instance?
I would say definitely it is reusable. It is designed, it's modular, it's componentized, and it's, as it's implemented in JUCE, just as each component and widget is very reusable in different contexts within that given project, those same, widgets and the design language they represent certainly could be reusable across subsequent products. That's a marketing decision whether or not to actually do that. But from a technological point of view, it would be extremely easy to reuse, those styles and those elements in a different configuration to create some future iteration or some further sibling product as well.
And technically, we definitely take it into account, so to make it possible if that would happen.
And
Yes, sir.
Sure.
Just wondered if any of the testing stuff you've added onto JUCE, is any of that going to be made available for other people to use?
So the question is if the code we've added for testing functionalities, if that's going to be made available. Maybe. I actually hadn't considered it, but might do it. We've contributed other parts, so yeah, totally. Yeah.
That's a good thought.
Yeah. Yes, sir.
Can you tell us like what hardware you're running on, like an ARM chip?
So the question is, can we talk about the hardware we're running on? No. Nope.
I'm just fascinated that you're able to use JUCE.
Yeah.
and
Yeah.
Can we, it seems safe to say, can I use the word system on a module?
Yeah, but
Sure.
that doesn't say much.
Yeah.
I think
Yeah.
that's about what we have time for. So.
Yeah.
I think so. All right,
Thanks a
thank you very
lot.
much.